This video is going to explicate some features and mechanics of the Juan de Fuca plate, the smallest but arguably one of the most important and active tectonic plates in the world. The Juan de Fuca plate is classified as a microplate because of its inferior size to other tectonic plates. The area of the Juan de Fuca plate is a mere 250,000 square kilometers, in translation about 96,000 square miles. In comparison, its neighboring plates, the North American plate and the Pacific plate, are respectively 76 million square kilometers, 29 million square miles, and 103 million square kilometers for the Pacific plate, which is about 40 million square miles. So pretty small in comparison to those two. Those are two of the largest tectonic plates. So the Juan de Fuca plate, as you can see right there, touching the Northern American and Pacific plates, it has a convergent interaction with the North American plate, as you can see in the diagram. Based on these boundaries, you see the blue with the little mountains is convergent, and then the pink is transform, and then divergent plate boundary is the teal. So as you can see in the picture on the right, the Juan de Fuca plate is sometimes split into three small territories, so the interactions are different, but in general, they say that the boundary between the Juan de Fuca plate and the Pacific plate is a transform boundary. As you can see in this diagram, the Juan de Fuca plate has a convergent interaction with the North American plate, as it is subducting underneath the Northern American plate and essentially shrinking. It used to be much bigger, and it was a different plate. As you can see, though, the Cascadia Trench within the Cascadia subduction zone is the site where oceanic crust is formed by eruptions along the Juan de Fuca ridge, and the plate then drifts eastward and cools, subducting itself under the less dense North American plate. Its interaction with the Pacific plate is in general, as I said, forming a transform fault. But when you consider the de Fuca plate as a three-part plate, as I earlier noted, the boundary is less cut and dry, and there are different interactions within those three subregions. However, generally, they slide against one another. The Juan de Fuca plate's lithosphere is topped entirely in oceanic crust. No part of the plate is above water, which is part of why the plate's movements are studied so much. The plate is part of the organs of the Cascade Range of mountains and the Pacific Ranges. And as in this, you see the black triangles on the right, on the green land part. Those are all mountain ranges and volcanoes, etc., that have been formed by the actions and subduction of the Juan de Fuca plate underneath the North American plate. So, yes, it forms mountain ranges. And the plate it's moving northeastward and subducting under North America at the Cascadia Trench at a rate approximated to be like 9.8 to 13.8 feet per 100 years. To break that down a little bit, it's about 1.5 inches a year on a good year. This is sort of in the middle relative to other plates, as some are only moving at a rate of about 0.5 inch a year, sometimes less, where others are moving almost 2 inches per year. Because tectonic plates move so slowly that it cannot be seen, felt, or tangibly measured, scientists use the global positioning system to measure movement and speed of tectonic plates. These systems of satellites positioned on Earth and in space offer information to scientists about movement of tectonic plates, as well as their relative velocities. So in here you see tectonism and volcanism of the last 1 million years, and you just see there's actively spreading ridges and transform faults, and you see spreading rates, which is in centimeters per year generally. So you can kind of see where the plates used to be, where they are now, and if they've shrunk, etc. So Thank you. That was my presentation on the Juan Fuca plate, and I will see you guys next week.